Okay, let's get started. I will give you first a little bit of history. I will give you a little bit of history about the exploration of space. Everything started a long time ago, long before I was born, long before you were born. And during the space race between two superpowers at the time, USSR and United States, it was realized that the weather in outer space is not steady, it's not quiet, but it can be quite stormy. And in 1958, there was a very special year. Basically, there were some coordinated investigations of the Earth's atmosphere in outer space, and one of the goals was to launch a satellite in outer space. And at that time, there were two superpowers in the world that can possibly launch a satellite. One was USSR and the other was NASA. It didn't exist at the time. That's how NASA was formed, back in 1958 or shortly after that. So anyway, the first satellite that was launched by NASA, Explorer 1, discovered that there's some donut-shaped regions encircling the Earth, so-called radiation belts, that contain some very high-energy electrons. Do you know what electrons are? Is there anyone who doesn't know what an electron is? Are you sure? What is an electron?
It's a particle that is charged.
Okay, what electric charge does it have? Negative. Very good. Okay, you know what electron is. Excellent. So, what they put on board this spacecraft is something that looks like this, very similar. It's called Geiger counter. It's a special instrument that can detect energetic particles, like very high-speed electrons. Each time an electron hits this detector, it goes as a bit, bit. Okay. So when they put this Geiger counter aboard the spacecraft, they were hoping to measure the radiation in outer space. What happened was there was so much radiation that the poor detector died because it was not designed to detect so much radiation. And that's the sad part of it. The good news is that we found that there is radiation belt. The bad news was that we didn't know that it was really so bad. And that posed some really big concerns for people at NASA and the other superpower USSR, because they wanted to send astronauts on the moon. In order to send them on the moon, they have to cross these radiation belts. And each time you pass through it, you immerse in this sea of fast-moving electrons that can go through your body and can cause all kinds of problems. Right? So, in a subsequent launch, they put a different Geiger counter, a more powerful one, who could detect stronger radiation, and then they figure out how much radiation really is in this radiation belt. And then they realized that, well, if the astronauts go through this radiation belt relatively quickly, then the radiation exposure shouldn't be that much. So it was okay. So that was the first discovery that there is some radiation in outer space. Then in 1958, the Soviet launched a spacecraft that orbited the moon. And this spacecraft made a fundamental discovery. It discovered a wind of particles coming from the sun. What is the solar wind made out of? Electrons, protons, and alpha particles. What are alpha particles? What's this? Helium. When you kick out the electrons from the atom, what do you get? You get helium nucleus. And that's what alpha particles are. These are the nucleus of helium. So anyway, this satellite provided the first evidence that the space between the planets and between the Earth and the Moon is not empty, but it's filled with matter. And in this case, it's the solar wind. And this solar wind emanates through the entire solar system. It starts from the sun, goes in all directions, and it terminates at the boundaries of the solar system. You can imagine the solar system being a huge cocoon surrounded by the interstellar medium, and this entire balloon is filled with the solar wind. Then we send people to the moon, landed on the moon, and we realized that there is additional danger out there. Namely, between one of the latest last missions, Apollo 16 and Apollo 17, there was a major solar flare. huge one. It took place on August 4. So if this flare were to take place on December 11 during the Apollo 17 mission, then the astronauts that spent a few hours on the moon would have been dead instantly on the spot. Why? Because they would have been exposed to an enormous dose of radiation over a period of a few hours. Would have been lethal. Just to give you an idea, the amount of radiation they would have experienced is about 1,000. This is not rapid eye movement. This stands for Röntgen equivalent in men. It's a unit that measures the dose of radiation that you get. Okay, it's a standard unit. Just to idea what this number means. If you live here back on Earth, you accumulate about 0.25 grams per year. If you live over a period of 70 years, this is how much radiation you get in a lifetime. 18. Unless you do something terrible like texting all the time, talking on the cell phone 5 hours a day, flying to Denver, or visiting nuclear power plants very often, or getting 100 CAT scans per year, then you should be okay. You should get about 20 grams per year. Okay? So let's compare these two numbers. Divide 1,000 by 20. What's the ratio? 50. You would have died 50 times. Okay? And the amount of radiation they would have gotten over a period of a few hours is 50 times the amount of radiation standard human beings experience in 70 years. So you get an idea of how dangerous conditions can be during a major storm on the sun. So later on, in 1973, people from NASA discovered that there is another solar phenomenon related to solar flares, and that's called coronal mass ejections. These are huge bubbles containing solar material and magnetic fields, and they're expelled from the sun, and they expand in space. And when they arrive at Earth, they create some dangerous conditions in the vicinity of the Earth that can create all kinds of hazards for spacecraft, for satellites, and for pretty much every single piece of technology out there, and also for some technology that is on the ground, and they can be also dangerous for human life.